There are two radical lessons in the radical unit. The first one is I give you the parent function y equals root x, right? And then I give you a function where it's transformed. And remember, the only thing that changes the domain and range when you have a square root of x function is your vertical and horizontal translations, because the square root of x starts at 0, 0, right? So the only thing that changes your domain and range is a horizontal and vertical translation, because you'll add or subtract to it. And the only thing that will change the inequality sign, which is greater than or less than, is greater than or equal to, is a reflection, correct? That's if I give you an equation and then give you a transformation, which is like 1 and 2. Then I said the other outcome was I can give you a linear, a quadratic, or a piecewise function. A piecewise function means they give you a graph in front of your face and you have to sketch the square root of that function that they give you. That would be the piecewise function that they give you. It would have pieces and you have to put it together. But when you do this, you're literally taking what your f of x is, so what your y is, and you're square rooting your y, correct? Like this, f of x equals 3x minus 1. I know people will see the f of x and they say, hey, that's my y. Yes, this is my y, but my y also equals this, so that's actually what y is as well, right? If I wanted to find the y of each of the on the graph, I would input for x and I get a y on this side, wouldn't I? So what am I doing? To get g of x, I'm just literally taking the square root of all the y's, hence why I get xy becomes x root y when they take the whole function and just square root it, right? And we know that invariant points happen when y equals 0 and y equals 1, because when I go y equals root 0, I still get 0. And when I go y equals root 1, I still get 1. We agree? So we're going to deal with 3 and 4 first. So to do 3 and 4 first, what we have to do is sketch the 3x minus 1 first. So I'll sketch it in red. So I know that it's linear, so it's easier to do. I don't even need to make a t-table. If I don't want to, I can use slope and y-intercept. So my negative 1 is my y-intercept, and then this is 3 over 1. So I go up 3, right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. And then I can do the complete opposite and go the other way. So instead of going up 3, right 1, I can go down 3, left 1. And I land on it as well. Now, the two important things as well are when y equals 0 and y equals 1, correct? So we're going to remember to practice this. We're going to go to our calculator. We're going to type in 3x minus 1. We're going to practice this. Go to your calculator. And you type in 3x minus 1. And then in y2, you're going to put 0, correct? Because we want to know when y equals 0. And if you have the older calculators, not the ones with color, you're going to go over to the slash on y2 and you're going to make it thicker so you can see it. And then you're going to press graph. And you should see two lines. You should see the 3x minus 1 line, which I typed in as plus. And you should see a thick line over the x-axis, which is 0, correct? And now you can go second, trace, intersect, enter, 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 and what do you get it at? 0.3333333 and 0. Bless you. Now I told you your calculator can turn that into a fraction for you. So we have x is 0.3333333, correct? Yes? Does everyone have that in front of their face? So go second mode, the button right beside second. Second mode. And now go x. I want to turn that x, that 0.333. Put x and hit enter. What shows up? The x value you just found, didn't it? If you go x and then go enter on your main screen, if you just go x and enter on your main screen, do you get 0.33333? Then you can go math, enter, enter, and it'll turn it to a fraction. So we have 3x minus 1, and then we have 0. And then I told you to go over here if you don't have the colors and hit enter so it makes it thicker. And then you have the graph. And then you go second, trace, 5, enter, 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 and it gets me 0.33333, correct? Then I want to know what that is as a fraction. I know it's 1/3 in my head, but some people don't. So we go second mode, we go to our main screen, and we can just press X and enter, and it'll show up in front of you. And it's going to change every single time you find a new x-intercept, correct? Right now my calculator, if I press X, like if I went 3x minus 1, let's say I just typed that into my main screen. Right now it's putting X in as 0.33333 because that's what my calculator believes X is right now, all the time. So if I go X, enter, and then I go math, enter, enter, it'll turn it to a fraction of a third. So if you get a decimal and it can actually turn to a fraction, go math, enter, enter. Now sometimes you get a decimal, it's like 0.275392, and it's like crazy decimal, and then people are like math, enter, enter, and they're like viciously hitting their calculator, and they're like, that's not it can't. It's a non-repeating, non-terminating decimal. Non-repeating, non-terminating decimals can't turn to fractions. No matter how hard you hit the math, enter, enter button, it will never turn into a fraction. Okay, no matter how mad you get at me, it will never turn into a fraction. So remember that. So we know at 1/3 and 0 is my x-intercept. It's also going to be an invariant point. So I'm going to plot that. I'm actually going to make it green because it's invariant. It doesn't change. Where's my other invariant point at? Where y equals 1. So I'm going to go to my y equals, and instead of having a 0 here, I'm going to put a 1. And then if I don't have colors, I'm going to go over here and I'm going to hit enter so that it's thicker. Correct? I just have colors, so I don't have to do that. Then I press graph, and now I did 1. Why did I do 0 and 1? They don't change when you take the entire square root of the function. Correct? They do change if it's the original where I transform graphs. They're totally different outcomes. This only works invariant for 0 and 1 when I take it, whatever function I give you, it has to be a linear, quadratic, or piecewise, but whatever function I give you in that options, and I tell you take the whole square root of it. There will always be invariance at 0 and 1 because when you do that, when you take a function and you take the whole square root of it, your mapping is xy becomes x root y. And the only y's that when you root them stay the same are when y equals 0 because it's 0, and y equals 1 because it's 1. So once again, I go second, trace, 5, enter, enter, enter. And now I get 0.666667, which I know is 2/3, but if I didn't, I can go second mode, and I can go x, my new x, is now that, math, enter, enter. It's 2/3. So my other one is at 2/3 and 1. Oh, in green. Now I made them green because they aren't going to change. On my new graph, those babies are staying the same, aren't they? And what part of the graph is going to actually exist? The part to the right of that x-intercept or the part to the left? To the right. So if I ask for domain, would I even have to draw the whole graph? No, I would know that the part to the right stinks, the part to the left negative y's. Right? I would also know my range is greater than 0 because my range is always greater than or equal to 0 if the graph actually crosses through the x-axis. So I'm going to connect my original. And this is f of x, I'm going to label it. Now to draw g of x, I already have 2 points on g of x. The 0 and the 1, correct? Then what do I have to do? I have to go along, and the 0.5, where this one is at 0.5, it's now going to be 0.7. Remember, it only just goes a little bit above. Because I told you, any y that falls between 0 and 1, when you square root, it gets a little bigger, right? Remember the square root of 0.5 was 0.7? Right? So it goes just a little bit above. So I always go to where 0.5 is and then just draw a dot a little bit above, because 0.5 is going to turn into 0.7, but my x isn't going to change. Then this one is at 0, or sorry, it's at 1 and 2. Then I go, okay, well now instead of it being at 1 and 2, it's going to be at 1 and root 2, correct? Well, the square root of 2 is 1.4. So I'm going to be at 1 and, oh, I do blue. 1 and 1.4. So I'm going to go through the greens to the blue. Now this one's at 2 and 5. It's now going to be at 2 and root 5. Can I pick more numbers in between as well? Yeah, I can pick as many points as I want, right? The square root of 5 is a little over 4, is a little over 2, sorry. So it's 2.23. So now I'm at 2 and 2.23. And then I have 3 and 8. It's now going to be 3 and root 8, which is a little under 3. .28. So it's going to be at 3 and 2.8. So my graph's going to do something like that. Pretend there's not a little ticky thing and that it actually goes through all the points. So what's my domain? XDR, that's in set notation. Or in interval notation, it's square bracket 1/3 to infinity. And it's square bracket of 1/3 because it actually starts there. Now I told you, if the graph actually cuts through the x-axis, whether it's a quadratic, whether it's linear, whether it's a different function that's in pieces, if it cuts through the x-axis, correct? Your range is going to be greater than or equal to 0 because it's just going to get rid of all the negatives. Unless, for example, the graph actually, and this is where people get it wrong, unless the graph actually maxes out somewhere. So I told you, if it was like a concave down parabola, let's say, yes, it's going to be greater than or equal to 0, but it's also going to be less than or equal to the square root of your maximum. So if your maximum was at 1,9, let's say, it's now going to be at 1,3. And it's going to curve and be in here, so it's going to be between 0 and 3. So if your graph goes through your x-axis, it will always be greater than 0, but if it has a maximum, it'll be less than or equal to that max. Square root of that max. Yeah. Yeah. So the range of this one, because it doesn't actually max out and it goes through the x-axis, is going to be y such that y is greater than or equal to 0, YER. Yeah. You would just do square brackets, low to high. It's the easiest one. So if they ever don't tell you what form you have to do and you're squishing it, but you're sandwiching it between two values, interval notation is always easier because it's number, square brackets, low to high. Yeah. Or round brackets if it's not equal to. Okay, let's go to this one. So I'm going to, for this one, I would type it into my calculator. I'm going to go to my y equals, I'm going to clear it out. And I'm going to once again get my zeros and my ones. I'm going to get my invariant points first. So 3x squared minus 2x minus 1 graph. That's my original, correct? But I'm going to get my invariant points first. So I'm going to go to my y2 and I'm going to put in 0. And if I have the older calculators, I'm going to go over here and I'm going to hit enter to make it thicker. So now I actually have 2x intercepts, correct? How many invariant points is this graph going to have? 4. It's going to have 2 where y equals 0. And it's going to have 2 where y equals 1, right? Because it cuts through 4 times. So we're going to go second trace 5. I'm going to go over to this one, enter, enter, enter. And I get negative 0.3333. Remember, if we can't remember what that is, x enter, math enter, enter. Oh, it's at negative 1/3 and 0. So that's going to be one of them. So I'm going to go here and put a dot in red, because I'm going to put all my invariants in red this time. Then I have to find the next one. Second trace 5, and I have to move over to the other one. Now you can either ride along the quadratic like I'm doing, or you can go shorter distance and you can just arrow up and pop yourself onto the line and move over quicker. Arrowing up or down, you can pop off of each different graph, right?
But then you need to go back up there.
Nope. You just need to be over near the other one. Yeah. And so I get 1, 0. So those are 2 of mine. Then I need the ones at 1. So I'm going to go clear out the 0 and put a 1. Then I'm going to get second trace 5, pop onto the line, enter, 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 and I get negative 0.54 and 1. And then, we're also going to go over if they ask us to do this algebraically, because they could ask for the invariant points algebraically as well. So it's at 1.23 and 1. How could we find these algebraically? It's at y equals to 0 and y equals to 1. So on the back, flip it over. There is a blank back for this reason. So we're going to find the invariant points of this one algebraically. So we know that y has to equal 0 for one of them, and we know that y has to equal 1 for the other. So we're going to go, and it's invariant, so we could plug it into the square root one, which would be stupid, because you'd have to just get rid of the square root by squaring it. Or you could plug it back into just the original one, right? Because the original one and the square root one should get you the same answers because they're invariant. So I know that my original function, I'm going to write up here, is f of x equals 3x squared minus 2x minus 1. So I'm going to go 0 equals 3x squared minus 2x minus 1. And then for this one, I'm going to go 1 equals 3x squared minus 2x minus 1. Now you have to find them algebraically if they ask you two ways. One, determine the invariant points algebraically. Giveaway, right? Dead giveaway. They literally ask for it. Or two, they ask for the invariant points in exact values. Now with those, we could have gotten away with our zeros, the ones where y equals 0 and exact values with our calculator. But we can't get away with where y equals 1 with exact values because we're going to have to use quadratic formula. So if they say ask for the invariant points as exact values, or they ask for the invariant points algebraically, you have to do it this way. You can't use your calculator. Okay? So for this one, we can factor. We can say what times what gets me negative 3. What plus what gets me negative 2. And often with the zeros, you can just factor. So we have to do decomposition. So it's going to be negative 3, positive 1, negative 3, positive 1. We go 3x squared minus 3x plus 1x minus 1. Group it. 0 equals, and this is all from last year, 3x, x minus 1, or plus 1, x minus 1. 0 equals 3x plus 1, and x minus 1. So this is just factoring from grade 10 up to this point. That's all just factoring from grade 10. And then last year in grade 11, you were taught, hey, we can actually just set each of these equal to 0 and get x-intercepts. That was the only extra step in grade 11. The first steps are all grade 10. Remember, grade 10 is always here to greet us. So we go 3x plus 1 equals 0. X minus 1 equals 0. 3x equals negative 1. Divide by 3. Hey, we're getting the same answer. X equals negative a third. And then plus 1. X equals 1. And people will sit here with it like this. But these are actually coordinates. What did I have? Y equals 0. So I actually have negative a third and 0. And 1 and 0. So those are my two invariant points algebraically when y equals 0, correct? Usually when y equals 1, it gets more advanced because you're often going to get a crazy decimal, which means you're going to have to give me a reduced exact value, which means quadratic formula. So I set y equal to 1, and then whenever I have a quadratic or anything with an x squared, I always have to move everything over to one side set equal to 0. That's the only way I can solve these, right? So my first step actually is to subtract the 1 over. I didn't have to with the other one because it was equal to 0. So I'm actually going to get 0 equals 3x squared minus 2x minus 2. And there's nothing that multiplies to me negative 6 and adds to me negative 2. So I can't factor it. So then I have to go to my quadratic formula. A equals 1. B equals negative 2. C equals negative 2. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah. It's totally a 3. Why did I write a 1?
It's 1, 3.
1 times 3, which is 3. I don't know, I don't know. So x equals, and that's the problem. You can do stupid mistakes and then it butchers your question. And you're like, what the heck was that? Why did I... Okay. So it's minus a minus 2, which is 2, plus or minus negative 2 squared minus 4 times 3 times negative 2. Now remember I told you you have to put this in brackets, because if you don't put negative 2 squared in brackets, your calculator will tell you it is negative 4, but you're smarter than your calculator, and you're going to be like, hey, negative 2 squared is negative 2 times negative 2, which is actually positive 4, and you'll stop yourself, hopefully. Or you'll just trust your calculator and get a wrong answer, which is scary. So don't do that. So then we get 2 times 3, and we get x equals 2 plus or minus the square root of, this is 24 plus 4, so 28. And then what do we have to do? Grade? Reduce grade 10. We're back to grade 10. Grade 10, grade 10, grade 10. So the quadratic part is grade 11, right? But the reducing is grade 10. We are going back to grade 10 all the time. Grade 10 is our friend. Okay. X equals 2 plus or minus. Now 28, root 28 off to the side, I'm going to reduce it. It's going to be 4 and 7. The 4 comes out and becomes a 2. So it's 2 root 7. So I'm going to get plus or minus 2 root 7 over 6. And now it's all three numbers or no numbers, right? So it has to come out of the front number, the number in front of the radical, and the bottom. It's a 3-for-1 deal always. If you can't do a 3-for-1 deal, you can't do any deals here. There's no 2-for-1 specials. It's a 3-for-1. So I can take a 2 out of all of these. This becomes a 1. This becomes a 1. This becomes a 3. And we're left with x equals 1 plus or minus root 7 over 3. And that actually gets me 2 coordinates. What?
I totally forgot that it's these days.
Ah. So I just was confused. Like I did write a 1 up there, so I could look wrong. So 1 plus root 7 over 3 and 1. And then 1 minus root 7 over 3 and 1. So there's my 4 invariant points. These, that, and that. In the notes today, yeah. Practicing. Okay, so we go back and we had plotted those 4 points, so we need more. So when we take it into our calculator, we get 3x squared minus 2x minus 1. And I have to get my minimum. Now, if it's concave up parabola, if it's a concave up parabola and it passes through, concave up and it passes through the x-intercept, your range will be y is greater than or equal to 0. Sorry, if we pass through the x-axis, right? Your range should be y is greater than or equal to 0. But watch yourself, if it's a concave down parabola, it's going to be a sandwich range. If it's a concave down parabola, because it's going to be between this, 0, and whatever the heck the root of my maximum is. It will always sandwich, right? Because it's concave down, this bottom will all go away, 0 will stay, and my maximum will squish down. Every single time it'll sandwich between two y values. So don't fall for that. So second trace minimum. I'm finding the minimum for fun because it's going to go away anyways, but what a joy. Okay, so we're at 0.333 and negative 0.333, so that goes down here. And then if I want other ones, I have negative 1 and 4. I have negative 2 and 15. That's way the heck off. I have 1 and 0. I have 2 and 7. And I have a few points. Now, if I want the graph to be more accurate than the very few little points that I took, I know that negative 2 gets it too big too fast, right? But I could go negative 1.5. If we go second trace value, negative 1.5, and that's at 8.75. And I could sketch it better than what I just did, because that would be here, right? So it would have curved and went up like that. So I can do better ones by picking smaller x values. Remember we said that? Okay. So there's my original. Now, if I go to draw my new, this is going to stay, this is going to stay, this is going to stay, this is going to stay. My 0.5s are going to bounce a little bit above to 0.7. So where my y is 0.5, it's going to literally go above its line, right? It's right above, just draw a dot right above. Because 0.5 is just going to pop up to 0.7. No matter what my x is, it's going to go straight up. 0.7. My 0.5 is going to pop up, my y at 0.5 is going to pop up to 0.7. My 1, negative 1 and 4 is going to become negative 1 and root 4, which is actually negative 1 and 2. So it's going to go here. So this is like the crappiest graph ever because I can't go any higher. And then this one's at 2 and 7. And it's going to go to 2 and root 7, which is between 2 and 3. I don't know, somewhere there. It's going to do that. Let's pretend those went through the dots. Yes?
You've already said this, but where do we put, because you keep saying the 0.5 in the squares and 0.7.
So like, for example, if I went here, I don't know what y 0.5 is. Like, I don't know what x correlates, but let's pretend it's at negative 0.5 and 0.5. Now it's going to be negative 0.5 and root 0.5, which is 0.7. So I would literally go to where my y is 0.5, with same x value, and just pop it above at 0.7.
And that's just to add points for accuracy.
That's just to add points for accuracy. If not, people will draw them straight through here. They'll just draw this blue line over, which isn't true. It actually curves out a bit. But it doesn't curve past this one, right? It just goes up a tiny bit, so it curves in a tiny bit. That's it. So it's just for a more accurate graph. So my domain is going to be x such that x is less than or equal to negative a third, or, we use the word or, I don't know why I capitalized it. I don't really want to erase it. It doesn't matter, you could have capitalized it. I don't know why I did. X is greater than or equal to 1. If I erase them, I've changed my marker size again. Stupid. XCR. Or, I cannot sandwich this one. Remember, sandwiching, so between negative 1/3 and 1 means it falls between negative 1/3 and 1. It doesn't. So if I went to go do interval, I'd have to go negative infinity, because remember this is the number line. It's going from negative infinity to negative a third, square bracket, or is the U. You get taught it in grade 12, 30-2. You guys, which means union, which means or. 1 to infinity. Yeah.
I wrote it down in like set notation. It was like negative 1/3 is less than or equal to x, which is greater than or equal to 1. Can I write it all in one row, or do I have to write the 4?
You have to write the or, because if you write it in one row, you're saying that it's and. Like you're saying that there's a number that exists that's less than negative a third and greater than 1, which there is no number that exists in the world that's less than negative a third and greater than 1. So if you try and list them together as inequality symbols together, that means and. The only time you can list them as a sandwich where it's like negative 1/3 to 1, it means that like there's literally the values fall between the two, which they don't. So if one shifts out this way, one shifts out this way, you have to list this inequality or this inequality. Yes.
Or, I have a simple question. If I was to write like the two domains completely separate, and I put or like between them, would that be okay? Or do you want it with?
They want it together. Like you're saying squiggly brackets one or squiggly brackets another?
Yeah.
Yeah, they want them together.
Okay.
Yeah. And then your range would be y such that y is greater than or equal to 0 in set notation, yer, or 0 to infinity. Then let's go up. So these were the other curriculum outcomes. These were, I gave you a parent function of y equals root x, and then I transform it. Some sort of transformation. So y equals root x, we remember that y equals root x is literally just the function this. Right? So the only thing that can transform it, because starting at 0, 0, is translations, which could move it from being not zeros, and reflections, which could cause it to flip. Correct? So these have not moved. There are no vertical or horizontal translations. So I know my x is going to be something 0 and my y is going to be something 0 because they haven't been translated. Correct? Then I look at my x is reflected in the y. So it's actually going to cause it to go this way. So it's going to be less than or equal to 0. This is a reflection, so it's actually going to cause it to also go downwards. So y is less than or equal to 0. It's reflected in both. So you should have had D. Now what they'll do is they'll give you a parent, they can give you a parent function, and then give you the transformations and not give it to you in an equation, right? They can give you the transformations with an f. So they could have written it, instead of saying function is this, they could say f of x equals root x, and then g of x equals negative f negative x. Means the same thing. This is just, hey, here's some transformations I'm applying to f. Here's, hey, the original was y equals root x, now it's going to be this. What am I going to do? Different way of asking the exact same question. Remember I told you they can go from radical, they can go from quadratic to quadratic. Now they can go from radical to radical, or they can go from radical to here's transformations with an f in it. Right? Asking the same thing. Okay, this one says the domain of the function y equals 4x minus 3 plus 2 is x is greater than or equal to k. Now what we can say is, hey, the domain is normally x is greater than or equal to 0. We know that. We have to remember to take our 4 out. So we get 4x minus 3/4. So what are we actually doing? We're moving it 3/4 to the right. Am I reflecting it at all? No. So it's going to be x is greater than or equal to 3/4. So you should have 0.75. Okay, we're going to flip back to our notes that I gave you. Not the 2 new ones, the radical notes that you were given. You should be here at example 3. Okay, so here, example 3. Example 3 says for each point on the graph of y equals f of x, which are listed below, determine the corresponding point. So your question on your test could be that easy. Here's a coordinate on f of x. What's the new coordinate going to be on y equals root f of x? So what happens? What's our mapping?
X, Y, root Y.
So I literally just keep my x's and root my y's. We agree? Because the entire function is under the square root symbol, correct? I took f of x, I'm now rooting the whole thing. So we're on example 3. Yeah. So we're going to get 3, 0 becomes 3 root 0, which is actually just 3, 0. So it actually is an invariant point, correct? You do B, C, and D. So here we're going to get negative 5 root 25, which is negative 5 root 5, or 5. Oh my gosh, I do what the grade 10s do all the time. Take the square root of 25 and write it as root 5. I just put one to that. It's not true. Square root of 25 is 5. Okay? And then this one is going to be 9 root 15. And then this one's going to be 4 root negative 16, which does not exist in our world. You want to write it because you want to show that that's why it doesn't exist. Yeah. You can write it as I would write it as root 15 unless asked for a rounded decimal. Yeah.
You have to put the words, right?
I'm checking with the head person. I just haven't emailed her yet. So I'm writing it as a full thing for now, but I'm going to check with her and see what she says. Okay, going to example 5. These are at a little bit of a tilt. You're welcome. I actually don't know what this black line that's drawn here is, but you're welcome for that as well. That's excess. These are out of your textbook. I printed them here so that you didn't have to actually go and redraw them out of your textbook. You're welcome. So even if they're slanted, this is better than you using pencil on my textbooks. They're not mine, but I feel like they are. And if I ask you guys to sketch a graph, I will always find someone who did the work on the textbook. And I'm like, that is not okay. So I'm stopping you from that. I printed it. So what they can do is instead of giving you, so some people in grade 10 and 11 have gotten away with typing the function into their calculator, never knowing transformations, never knowing anything, and literally just sketching it off their table of values and stuff like that. Well, grade 12 stops you from that because they will give you an equation, but not tell you what the equation is. They'll give you like a graph of it. So now no longer can we just type it in. We actually have to know our rules. So if we look at example 5, we're going to match these to the ones down here. So what we have to do is we can use our knowledge and match them really quickly. Or we can actually sketch the whole thing. So what I'm going to do is I'm going to go always to where or y equals 0 and y equals 1, and I'm going to immediately put invariant points. So I can do that on all of these. This one's slanted, but just pretend that it's not. Like I'm just like, look at these. These are great. They're so lovely. I like you. You're good. I just invariant pointed the crap out of all of these things. Didn't even see me coming. That's how fast I did it. Okay? Now, we know that all the negatives go away. We agree? But if I wanted to actually sketch these accurately, I could actually go right away now and say, okay, A, it's going to only keep to the right, so it's going to match C. And then I could be like, B, its arms are going to go out, its arms are going to go out, it's going to be A. And then I can be like, C. Well, it's going to stay in between. That maximum's going to slide down, shimmy it to, D. And then I can be like, the other one's linear. The bottom goes away. The left side's going to stay. C. I could do that. Do you agree? But how do I actually sketch it if they don't go match it? So for the first one, I would sketch my invariants. I would go to 0.5 and just draw it straight above, right? Like I would go to where what? And then it just made they're all attached, but whatever. Then I can go along to any of them and actually take the root of them. So this one here is at -1 and 3. So now it's going to be at -1 and root 3, which is 1.73. So it's going to go here. This one's at 0 and 5. So now it's going to be at 0 and root 5. So this is even faster than what we did before because they literally give us all the points. We just map them by rooting the y's, right? Our xy becomes x root y. Our xy becomes x root y. And same thing here. So then that would just, I can go 1 and 7. Root 7 was in between. Oh, goodness. So it's 2.6. Yeah, 1 and 2.6. And then, boom, I go like that. This one, you do the same. It's at 0 and 5, so now it's at 0 and root 5. This one's at 6 and 5, so now it's at 6 and root 5. And we have ourselves our little graph because our 0.5 is going to become 0.7s, right? This one, our 0.5 is going to become 0.7, so it's just going to be drawn a little bit above. And then this one's at -4, and 3, so now it's going to be at -4 and root 3, which is 1.7073. So it's going to be here. So if I went to draw the range for this one, I wouldn't go 1.73. My range, if I went to go do it, would be 0 to root 3. Like I would literally write the exact values. That would be my interval. Or it would be y such that 0 is less than or equal to y is less than or equal to root 3 yer. And my domain would be sandwiched between some weird decimal, which I don't know. And this one would go to 0.7, 4 would drop down to 2, and it would go like that. Right? And then they would match. So that we can go through the rest of these notes quickly tomorrow, your homework is actually going to be doing examples in here. So you're going to do example 6, where I just state the domain and range of these. Remember, they're going to be completely square rooted, right? So you're going to have to look at them to help you out. This one is going to be a positive slope, right? So I know that it's going to be to the right. This one is concave up, but it's actually completely above 0, 2. So it's going to be like this. So keep that in mind for your range. It's not going to be from 0 to something. This one is actually like this. So it's going to round and go these ways. Less than -2 and greater than 2. And this one is like this. So it's going to sandwich. So they're all set up with different things, different ways. So you can do example 6 tonight and example 7, where I just give you the function and you have to sketch the root. And then you're going to explain example 8, and we're going to go through them quickly tomorrow. So that's your homework for tonight. Yeah.